Welcome to Inside Factory Walls, where we explore how discarded industrial oil drums are magically transformed into heavy-duty railway tracks. Millions of empty metal barrels are abandoned at the scene, creating a massive environmental challenge that demands a highly innovative solution. Instead of letting them rust away in endless landfills, specialized recycling plants give this scrap metal a powerful new structural purpose. Today, we will take a deep dive into the fascinating industrial journey from toxic waste to the backbone of modern transportation. The incredible process begins right here at the collection yard, where mountains of old containers await their ultimate fiery metallic rebirth. Massive industrial cranes equipped with powerful electromagnetic attachments sweep across the yard, effortlessly lifting dozens of heavy steel drums at once. These gigantic machines carefully transport the bulk material toward the initial sorting facility, initiating the first step of this amazing transformation. Workers and automated scanners meticulously inspect each incoming barrel to ensure only suitable cargoes. Materials proceed to the next phase, and drums containing highly dangerous chemical residues and non-metallic components are safely separated and routed to specialized hazardous waste facilities. Once sorted, the approved barrels are placed onto heavy-duty conveyor belts that carry them deep into the primary processing building. The deafening roar of machinery fills the air as these battered containers move steadily toward the rigorous cleaning and preparation zone before any melting can occur. Every single drop of residual oil and chemical sludge must be completely drained from the barrels. Automated puncture stations pierce the thick steel walls, allowing the thick dark liquids to flow into secure underground collection containment tanks. High-pressure industrial washing systems then blast the interior and exterior surfaces with a powerful mixture of hot water and solvents. This crucial decontamination step prevents explosive reactions during the melting phase and ensures the final steel product maintains optimal structural purity. With the cleaning complete, the pristine steel drums are forcefully pushed into the jaws of a monstrous industrial mechanical shredding machine. Massive wood-bearing blades with hardened steel teeth easily tear through the metal barrels, ripping them into hundreds of jagged smaller pieces. The violent shredding process dramatically reduces the volume of the scrap, making it significantly easier to handle and melt down later. A secondary magnetic separator passes over the shredded fragments to remove any lingering aluminum or plastic debris mixed within the pile. Next, these clean steel shreds are fed directly into a gigantic hydraulic press capable of exerting thousands of tons of pressure. The immense crushing force compacts the loose metallic fragments into dense rectangular bales, perfectly sized for the electric arc furnace feeding. Forklifts transport these heavy metallic blocks across the factory floor, stacking them neatly in preparation for the extreme high temperature melting. Now in the part of the recycling facility, the foundry, where raw heat will completely alter the state of matter. The compacted steel bales are loaded into massive buckets and hoisted high above the yawning mountain. Electric arc furnace. With a spectacular shower of bright orange sparks, the scrap metal is dropped directly into the glowing belly of the beast. 3 massive graphite electrodes are slowly lowered into the furnace, sending powerful electrical currents surging straight through the dense steel blocks. The intense electrical resistance generates unimaginable heat, rapidly pushing the internal temperature well above 3,000 degrees Fahrenheit per mere minutes. Slowly but surely, the solid metallic scrap begins to liquefy, transforming into a brilliantly glowing pool of molten liquid steel soup. During this intense melting phase, specialized chemical fluxes are carefully added to the liquid bath to draw out unwanted chemical impurities. These impurities float to the surface as a layer of slime, which operators skillfully skim away to reveal pure liquid steel. A massive ladle transports the glowing liquid metal across the dark factory ceiling, glowing like a captured miniature sun in transit. The molten steel is then carefully poured into the continuous casting machine, marking the beginning of its transformation into solid tracks. As the liquid metal flows downward through water-cooled copper molds, the outer edges begin to solidify into a continuous shape. This semi-solid strand of glowing red steel is gently guided along a curved pathway by a series of heavy rollers. Powerful water jets spray the moving metal continuously, rapidly dropping its temperature and forcing the inner core to solidify completely. Solid, automated oxy-fuel torches slice the endless strand into perfectly measured rectangular blocks. In the heavy steel industry, it has Blooms. These massive steel blooms still radiate intense heat, glowing a vibrant cherry red as they travel down the heavy roller cables, before they can cool down entirely. And the heavy blooms are swiftly transported into the massive reheating furnace for the next phase. The reheating furnace ensures the steel reaches a uniform temperature throughout, making it perfectly malleable for the upcoming rigorous rolling process. Exiting the furnace, the glowing hot bloom enters the breakdown mill, where the real physical shaping of the railway track begins. The heavy metal passes back and forth between gigantic cylindrical rollers, gradually reducing its thickness while significantly increasing its overall length. High-pressure water escape jets blast the surface during it, violently stripping away oxidized iron scales to a flawless finish. With each successive pass through the heavy rolling stands, the rectangular steel bloom begins to resemble the iconic railway track shape. Specialized grooved rollers carefully sweep the hot metal, precisely forming the distinct white base of the narrow web and the thick head. This continuous shaping process requires absolute precision, as even a millimeter of deviation can compromise the safety of a future train. The steel stretches longer and longer, transforming from a short chunky block into a sleek continuous ribbon of glowing hot track, traveling at impressive speeds. The fully formed rail finally emerges from the last finishing stand, completely shaped and ready for cooling. The red-hot tracks are automatically transferred onto a massive cooling bed, where they will slowly return to normal room temperature. This controlled cooling process is absolutely critical, preventing the metal from warping or developing dangerous internal stresses that could cause fractures. As the rails cool, their color shifts from bright glowing orange to a dull gray, revealing the final hardened steel surface, once completely cooled. The tracks are sent through a specialized roller straightening machine to eliminate any minor bends from the cooling. Hydraulic presses apply calculated pressure along the length of the steel, ensuring the rail is perfectly straight from end to end. Now begins the rigorous quality control phase, where advanced technology guarantees the structural integrity of every single inch of the track. Automated laser scanning systems measure the dimensional profile of the rail, verifying that the width and height meet strict international standards. Any rail that fails to match the exact mathematical specifications is immediately rejected and sent back to the furnace for REM-LTING. Next, an ultrasonic testing machine glides along the steel surface, sending high-frequency sound waves deep into the solid metal. This non-destructive testing method detects microscopic internal cracks or hidden areas that could lead to catastrophic failure under pressure. Highly trained technicians closely monitor the digital readouts, ensuring that only flawlessly manufactured steel rails receive the final stamp of approval. After passing all rigorous inspections, the continuous tracks are moved to the cutting station to be sliced into standard commercial lengths. Massive circular carbide saws slice effortlessly through the hardened steel, creating smooth and perfectly square ends for seamless track joint connections. Automated drilling machines then bore precise holes into the ends of specific rails, allowing them to be molded securely together later. Finished steel rails are finally stacked using heavy magnetic cranes, forming massive bundles ready for immediate distribution across the country. It is truly remarkable to witness how dirty industrial waste can be engineered into something so vital for global public transportation. These tracks will soon support thousands of tons of cargo and millions of passengers. Enduring decades of extreme weather and friction, every single oil drum that went into this process has effectively been saved from polluting the and given new life. The recycling of steel requires significantly less energy than mining raw iron, making this entire operation a massive environmental victory. Heavy freight trains arrive at the factory loading dock, ready to transport the newly minted rails to active construction sites nationwide. The freshly loaded steel gleams under the bright industrial lights, standing as a proud testament to modern engineering and sustainable manufacturing. Track laying machines will eventually position these exact steel rails across vast open landscapes, connecting distant cities and driving economic growth. What once held toxic industrial lubricants will now safely guide high-speed passenger trains safely across towering bridges and deep valleys. This infinite loop of metallic recycling ensures that precious natural resources are conserved while building the necessary infrastructure of tomorrow today. The factory floor never stops moving, as the next enormous batch of crushed oil drums is already being loaded into furnaces. Day and night, the massive electric arcs flash, continuing the endless cycle of intense destruction and beautiful creation within these walls. We hope you have enjoyed this incredible behind-the-scenes look at the records. Transformation of scrap metal into railway tracks. The journey, from a rusty discarded barrel to a polished structural masterpiece, highlights the unbelievable ingenuity of modern heavy industrial recycling. Next time you ride a train, remember the fiery origins of the and the recycled history of the steel tracks. Our world depends on these hidden industrial processes to keep moving forward while simultaneously cleaning up the mistakes of our past. Thank you for joining us on this fascinating mechanical journey through the extreme heat and heavy machinery of the steel foundry. Please like and subscribe for more amazing deep dives into the incredible manufacturing processes that quietly build our modern, civilized world. Stay curious, keep exploring, and never underestimate the hidden potential locked inside the everyday objects we carelessly throw away without thinking. This has been Inside Factory World, signing off until our next incredible industrial adventure into the fascinating heart of modern manufacturing.